When we estimate a simple linear regression model, what we would like to know is whether the independent variable x really contributes to the prediction of the dependent variable y. And this is the same as testing if beta 1, the slope coefficient, is equal to 0 or not. To do that, we will use hypothesis testing, the one that we are very much familiar with. So the null hypothesis is that beta 1 is equal to 0, so that there is no relationship between y and x, so x does not contribute to the prediction of y, and the alternative hypothesis is that beta 1 is not equal to 0, so x contributes to the prediction of y. To test this hypothesis, we will estimate the test statistic, and which will be t statistic, and to do that, we will take the estimated value of beta 1, subtract the hypothesized value of beta 1 from the null hypothesis, which is 0, and divide by standard error, or as we know, a standard deviation of beta 1. To calculate the standard error or the standard deviation of the slope coefficient, we need to use this formula, where s is the square root out of sum of squared errors divided by n minus 2. And to get the sum of squared errors, we will use this formula. And as you can see, the sum of squared errors is equal to the sum of squared difference between the actual value of y and its predicted value. Or we can also calculate it as ss of yy minus beta 1, so the estimated beta 1 multiplied by ss of xy. And to get ss of y, we will use this formula. So we have two formulas. So the first formula assumes that this is the sum of square difference between the actual value of y and its sample mean. And the second possibility is to take the sum of squared values of y and subtract the squared sum of y's divided by n, which is the sample size. And here is the table which quickly summarizes three types of tests we've got, so negative-tailed, positive-tailed, and two-tailed test. The null hypothesis is the same as always, that beta 1 is equal to 0, and the alternative hypothesis is different for each test. So in case of the negative-tailed test, the alternative hypothesis is that beta 1 is lower than 0. In case of the positive-tailed test, the alternative hypothesis is that beta 1 is higher than 0. And as for the two-tailed test, beta 1 is not equal to 0. And as always, we reject the null hypothesis when, in case of the negative-tailed test, the estimated t-statistic is lower than the negative value of the critical t-statistic at the significance level of alpha. We reject the null hypothesis for the positive-tailed test when the estimated t-statistic is higher than the t-statistic at the critical level of alpha. And as for the two-tailed test, we reject the null hypothesis when the estimated t-value in the absolute terms is higher than the t-value at the level of significance alpha over 2. Or we can also use the p-value. So when the estimated p-value is lower than alpha, the level of significance 1, 5, or 10%, we also reject the null hypothesis. In addition to doing hypothesis testing, we can also construct a confidence interval for the regression slope beta 1, and it's done in the following way. So the lower boundary is equal to beta 1 multiplied by the critical t-value at the level of significance alpha over 2 multiplied by standard error of beta 1, and the upper boundary is beta 1, the estimated value of beta 1, plus the critical t-value at the significance level of alpha over 2 multiplied by standard error of beta 1.